Hello, my name's Mike Brunt and my company's Go-To-Ria, and we specialise in tuning and troubleshooting cold fusion and Java server issues, web server issues to be more succinct. So this is the second in a series of videos where we're hoping to bring information to people about how effective load testing is and how essential it is in every case, and this is based on years of doing exactly that for clients. So we started a series of load tests yesterday relating to an application that's not performing well. User came to us and said we can hardly get past 5 concurrent users, which is nothing. And sure enough, by homing in on the code and the site, we were able to identify the area where the problem comes from and create a series of load tests related to that. And typically how we do that is we start with a low number of users, and then we increase until we hit a point where the application won't go any further, and we're tracking the requests in the tests, and we can see from that which requests are causing a problem. And in this case, what we found is that this was a process that was a very heavy-duty process that couldn't be written out or improved inside the code itself. But what we were able to do is bring relief by employing an external caching mechanism, beg your pardon, which sits in between the router or the firewall and the web server cum CF server and caches content that doesn't need to be dynamic with each request. And as you'll see in a minute or in a few seconds, the results of that have been fairly dramatic. And what we did is a 15 virtual user test. So we got up to a 15 virtual user test, concurrent users that is, which is not a very high number again, but at that point the non-cache version basically fell over and errored out 100%, or beyond that it did. So here's the results of that test, and we'll see. So what we're looking at here, hopefully you'll be able to see this okay, is these are two sets of load test results. The top set of results shows the test running before any caching was employed, and the second URL, if you can see it, I'm going to point to it here. Basically what it says is that the average request time was 66 seconds. There were, in the period of the test, which is 5 minutes, there were 29 clicks and 14 of them errored out. So we had a 50% error rate, ridiculously unacceptable times of course, which is 66 seconds. The result of that in the end result here of the test is that of the 209 clicks in that 5 minutes, 14 errored out, which were all this second URL, and this made the actual average response time in the test hit 9 seconds, which is, mostly speaking, is totally unacceptable for users, So then we employed the caching mechanism, and the second set of results here is the same, exactly the same test running for the same period of time with caching on. You look at URL 2 now, there were actually 57 clicks as opposed to 29 prior to caching. There were no errors at all, whereas before there were 14 errors, and the overall result is dramatically different. If we extrapolate this out to real world numbers, what we actually got was a load test with no errors and 450 clicks, as opposed to a load test with 14 errors and 209 clicks. So that's over a doubling of the number of clicks, and the effect on the actual response time is even more dramatic. From an average response time for that test of 9 seconds, we dropped down to 1.8 seconds. So that is an immense improvement in performance.